Well, welcome back. This should be a fairly short video lesson here on indirect measurement. And an indirect measurement allows us to use properties of similar polygons that we've been talking about to find distances or lengths or different things that we're looking for that might be too difficult to measure directly. So one of the ways we can use indirect measurement is called shadow reckoning. And it's basically comparing the shadow of an item to its original size so that we can find the height of something else that's difficult to measure. So for example, we have a fire hydrant right here, this little red fire hydrant, and it's 2.5 feet tall, and it casts a shadow that's 5 feet long. We want to know how tall this street lamp is if its shadow is 26 feet long. Well, if we let h represent the height of the street light, we can write a proportion where we have the height of the shadow of the hydrant over the height of the street light is equal to, I think I messed that up. So the shadow, the length of the shadow of the hydrant over the length of the shadow of the street light, there we go, is equal to the height of the hydrant over the height of the street light. Okay, so we can then cross multiply, use our cross products, and we'd have 5 times h equals 2.5 times 26. If we multiply this out, we get 65. To get h by itself, we need to do the opposite of multiplication, which is dividing by 5 on both sides. So h works out to be 13. And we could have figured that out pretty easily. If we just looked at our example, we could see that the shadow for the hydrant was twice as long as the height. So this shadow should be twice as long as its height. And since that's a proportional relationship, that is true. Here's another indirect measurement, using similar triangles. So we have a lake right here, and triangle DBA, which is the smaller one right here, DBA, is similar to triangle ECA, the bigger triangle. And we want to know what is the distance across the lake from E to C, and we're going to call that distance little d, and M is just for meters. So what we're going to do is we're going to use similar triangles to figure that out. So we're going to set up a proportion where we know that AB corresponds to AC, right? So the length from A to B corresponds to the length from A to C, and the length from B to D corresponds to the length from C to E. So we're going to use the proportional sides. So AB over AC equals BD over CE. Okay, we're just using those proportions and setting those up. Now let's just substitute in the numbers for what we know. We know that AB is 320 and AC is 482. Where did the 482 come from? Well, we know B to C is 162 and A to B is 320. So we have to add those two, and that's where the 482 comes from, AC. The distance from B to D is 40, and we're looking for the distance from C to E. We're going to call that little d. So now we can do the cross products. We get 40 times 482 equals 30, or 320 times d. To get d by itself, we need to divide both sides by 320, and we get d equals 60.25. So the distance across that lake is 60.25 meters. All right, I've got 3 examples for you here to try on your own. You are given the height of a dog right here is 0.45 meters, and the length of his shadow right here is 0.3 meters. And the length of the shadow of a tree is 2.2 meters, and you want to find the height of the tree based on the height of the dog and his shadow. So set up a proportion there and solve for that. And then we have similar triangles here. Find the length of Kentucky Lane. Kentucky Lane is the hypotenuse of the big triangle, okay, given the information that you have from the other triangle sides. And then lastly, walking, find the distance from the park to the house. So here's the house, and here is the park. You want to find that total distance all the way across right here. This distance D you have to figure out. You're given the distance 5 right here, so you need to find the length of the side of this triangle right here. All right, bring those answers to class with you, and we'll see you next time.